Okay, let's do a few more transformations, guys. Let's look at problem number 1. For problem number 1, what is the parent function? One more time. What is that called? Yeah, let's write absolute value, and I'm just going to abbreviate. And then there's only one transformation. What kind of transformation is happening in problem 1? Yes, vertical stretch by a factor of. Very good. These always go together. And it is by a factor of 3. Where's the vertex for this transformation? Let's plot it. Good job. Now again, guys, remember we are going to go sideways over 1, but your output is being multiplied by 3, positive 3. So when I go to the right 1, how many do I go up? Very good. And when I go to the left 1, I still go up 3 because it's absolute value. Going back to the vertex, what if I go 2 places to the right? How far do I go up? Very good. And then, guys, always draw your arrows. Always utilize the full picture of the graph. All right. That's it. Let's go ahead and take a look at this next one. This is not absolute value. What is this one called? Yes, let's write quadratic. Lots of transformations. What do you guys notice about this? Vertical reflection, yes. What else? By a factor of 2. What else you guys got? Left 2 places, and then what? Up 3. Very good. Let's go ahead and plot HK. Remember, HK is going to be -2, positive 3. And be careful, because I can go over 1 on each side. But remember your movement chart, all of those outputs for the quadratic are going to get multiplied by a -2. So when I go to the right 1, how far do I go down? Very good. When I go to the left 1, how far do I go down? Good. Now be careful. When I go to the right 2, how far do I go down? Remember, we're right here on quadratic. How far do I go down? Yes. You multiply your outputs by the -2. That's a pretty far drop. So be careful and make sure you count correctly. Over 2, down 8. All right, so guys, on this quadratic, please do your absolute best to make sure it looks like a quadratic and not like an absolute value. Please try to make your vertex as round as you can. I know these graphs are kind of small, but do your best. And that's going to be it. Any questions on problem 2? All right, y'all. Problem 3. Here we go. What is that one called? Cubic. You only have one transformation. What is it? Compression. Yes, by a factor of 1/2. So remember, we're still moving sideways. Over 1 to the left and right. Over 2 to the left and right. But look, all of these outputs are going to be cut in half because you have a vertical compression of 1/2. So when I go over, and there's no HK, so draw a dot in the center, just like a regular parent function, draw a dot in the center. When I go over 1, how far do I go up? Very good. Estimate where your 1/2 is. Same in the left direction, go left and go down to 1/2. But the next set of movement is going to be right on the grid line, guys. When I go 2 places to the right, how far do I go up? Perfect answer. Go ahead and make your opposite movement also. Now again, guys, don't forget for the cubic, it kind of has a swirl at the origin. So try to draw your best to do that. I know it's a kind of a small graph, but do try to show that behavior, and then don't forget your arrows. Any questions on your cubic function? Okay, the last thing we're going to talk about, guys, is not looking at a graph. We're just going to look at words, and we're going to write the equation, and we're going to wrap this up. All right, so let's go ahead and take a look at number 4. Number 4, we're going to write a quadratic function that is translated 2 units to the left and 3 units up. Please remember it is opposite in the equation. So they don't tell me how to write it, but they do tell me it's a function. I'm just going to use q since it's a quadratic. So q of x is going to equal, guys, what gets dropped in these parentheses? X plus 2. Great job. Don't forget your exponent for quadratic, and then go ahead and write plus 3. All right, let's look at problem 5. For problem 5, we have a horizontal compression by a factor of 3. Listen, you guys really don't have that much review when it comes to horizontal compressions. So I would highlight this or circle this because, again, you do need to know it, but there's not a whole lot of practice in this packet. And I know you guys didn't do too much with horizontal compressions in Algebra 2. So listen. Just very similar. You know how we put the opposite in here for your h value? Opposites belong to h's. Reciprocals belong to horizontal compressions and horizontal stretches. Please write the word reciprocal to kind of remind yourself you're not going to change the sign. You're just going to flip it upside down. So let's go ahead and write, I'm going to write c of x because it's cubic. That's fine. And then this horizontal compression, that 1/3 needs to be flipped upside down. What does that look like? Good, it's a 3. But you have to put it in parentheses. It has to be forced in a group with x. Don't forget your cubic exponent. And now you can go ahead and write minus 5. The k doesn't change. So write minus 5 for 5 units down. That's how we're going to write that. All right, let's go ahead and knock out this square root function. So s of x is going to be a 1/8 out front. Guys, what goes in here? X plus 1. Yes, yes, yes. Over here, minus 4. Great job.